Welcome to Spring LIB.
All right, we have an alkene as our substrate. And that alkene is undergoing a reaction with mCPBA. mCPBA takes alkenes and turns them into epoxides, which are also known as alkene oxides. They behave very similar to alkenes. The important thing to remember with epoxides is that if two groups are cis to each other across a double bond, they will remain syn about the epoxide. And the other two groups, if there were two groups on that epoxide, would remain, draw them as being syn as well. So anything that was cis on our alkene will be syn in our epoxide. Okay. So let's note that this cyclohexane and a hydrogen that's not pictured are cis. This methyl group and a hydrogen that's not pictured are cis. Okay, so we're going to have our what was our double bond will now be an epoxide. Okay. We'll have our hydrogen and our cyclohexane. Okay. And then we'll have, these are syn to each other. And then we'll have our hydrogen and our methyl group. Oops, it's a methyl group, not a hydrogen. Will also be syn to each other. Another way that you could draw it, if it helps you, is to not draw wedges to the oxygen, but instead draw them as being the bonds to the oxygen as being flattened in the plane. And then the idea is that anything cis to each other on the double bond will both be on wedges. So I'd say wedge to hydrogen, wedge to cyclohexane, and dash to hydrogen, dash to methyl. Right? That's these two are both on dashes, and these two are both on wedges.